All right, here we go with part 3 of our semester spring 2017 review, because why not? Okay, so starting with problem 54, we're getting into radical equations, which we did cover. So all these types of problems we're going to look at. The idea is that you want to solve these types of problems, get the radical by itself, then you square the number, and then you could say solve for x. Okay, so something like this would suggest that, like, okay, first we need to subtract the 3, and you get 8. So you got the square root of 5x minus 1 is equal to 8. And then you would say, to get rid of the square root, you would square, and that would give you 5x plus minus 1. Notice how the square root disappears, is equal to 64. And then you solve for x, so add 1, 5x is equal to 65, and then you can divide by 5 to get x is equal to 13. Okay, obviously you could check your work, say 5 times 3 is 63, 5 times 13 is 65, minus 1 is 64, square root of 64 is 4, 8, and 8 plus 3 is 11. Easy check, there you go. So all these problems, 55, 56, 57, 58, are kind of like that. So you would just kind of work through those. See here, I've got x minus 1 plus 10 equals 3. So I would subtract 10 and get square root of x minus 1. Notice once you have the square root by itself, then you can square a number, and every time you square it, you will get a positive answer. So you have x minus 1 is equal to 49, and then you can add 1 to get 50. Okay, fairly simple to do those types of problems. 56 is similar. Square root of 6x minus 1 plus 1 equals 5. Subtract 1 from both sides. Minus 1, you got 6x minus 1 is equal to 4. And then square that, and you've got this equal to 16, because we squared. And then we have 6x is equal to, add 1, you got 17. And then divide by 6, and you get 17 over 6. Okay, so here's 57 and 58, and what I'll do is I'll go ahead and say, go ahead and let them play through. You don't need me always to kind of constantly explain they're the exact same steps. They would do the exact same things. Notice that you would add 2, then you can say square. Remember, once you get the radical by itself, whatever's under the radical, under the square root, you would square the number outside, but then you would then you would just say combine the start doing solving from there. These are basic steps that you should be able to know how to do, because again, these are just basic algebra skills that you should be just fine with. Okay, and I just want to let them play through because, well, there's that short and easy. Final one. Let's look at 59. Okay, so here you can see here I subtracted 8. Got me 20 minus 8 is 12. I squared the 12 to get 144. Notice how the radical dropped. Subtracted 7 to get 137, then divided by 4 to get 137 over 4. So that's really about it for those, and that's what we're going to work on. So then I looked through the next section, and 60 through 61, which is solving the given inequality, we basically said no. So we're not going to do 60 through 63. You can omit. Alright. Okay, so let's look at 64. And we're going to solve exponential equations. So we have 8 to the 7n minus 9 is equal to 1 over 4,096. Again, this is where it would be helpful to have your tables, so that you can realize that when I look at 8, I got 8 to the first is 8. 8 squared is 64. 8 cubed is 512. 8 to the fourth power should be 4,096. So that would also suggest that 8 to the negative 4 power is equal to 1 over 4096. Don't forget that the negatives are the reciprocals of those. So to put this into the same power, I have 8 to the 7n minus 9 is equal to 8 to the negative 4 power. So I'm changing this to the negative 4. Now that they're the same base, I can drop that and just say 7n minus 9 equals negative 4. And I can just start solving like I normally would. So add 9 and then divide by 7 to get n equals 5/7. Ooh, we're getting a lot of fractions. Oh no. Okay, yeah, I'm going to let y'all have a a note page, not a note card. Yes, you can use front and back. Okay, because you're going to need stuff like this. Like, you would have to know that 625, 5 to the first is 5, 5 squared is 25, 5 cubed is 125, so 5 to the 4th power is 625. And of course, if it's fractions, think negatives. Okay, so that means this is 5, 6n plus 5, and 625 is 5 to the 4th, so that means I can get rid of the 5s and say 6n plus 5 is equal to 4, and then I can subtract 5 to get 6n is equal to negative 1, so n is equal to negative 1 over 6, because I can divide, and there I go. So you can kind of see how those can be done. It really shouldn't hopefully be too hard. Alright, let's get back to some easy stuff. How can I rewrite in logarithmic form? Alright, so now you got to go from logarithmic form to exponential form, and exponential form to logarithmic form, you know, stuff like that. What's the easiest way to do this? What's a way that I can always do this? Well, if I go to logarithmic form, that means I want logs. Oh, that ain't going to work. Blue is not going to work because my shadow was just blocking that. So we're going to yellow. Okay, so we want log. Okay, log base 11 because that's the number I have here. And then I'm going to want log base 11 next to this number. Can't write that because I run out of space. The log base 11 and 11 cancel each other out, leaving me a 4 is equal to log base 11. That's 11. Just go with that. 14,641. And that's it. You're done. Keep in mind that when you do this, you're thinking there's the base, there's the exponent, and there's the answer. Okay? So if I do the same thing here, log 5, 5 negative 2, and then put log 5 for this, then these would cancel each other out, leave me negative 2 is equal to log base 5 of 1 over 25. Go in reverse. You see the 7, put a 7, put a 7. These cancel out, leaving you 1 over 49 is equal to 7 to the negative 2. You see a 2, you see a 2. These cancel out, leaving you 1 over 64 equals 2 to the negative 6. Keep in mind that these are talking about switching the form, so you just got to make some changes. And there you go with those. Okay, so let's evaluate. How can I evaluate number 70, log base 7 of 2401? Okay, just type that into the calculator. I mean, if it's something like this, all you got to do is type it into the calculator, and you should find out that answer is 4. Okay, so log base 8 of 164, 1 over 64, I would type that into the calculator, and you would get an answer of negative 2. Simple, easy peasy, I know. Alright, number 72. Oh no, now we've got a variable. Log base 27. That is a horrible looking 2. Let's try that again. Log base 27 of n is equal to 8/3. Okay, honestly, the easiest way to do this is just remember base, exponent, answer. So this is really just saying 27. This allows you to do that whole, change it to exponential form. 27 to the 8/3 power. Type that into the calculator, and that would tell you what the answer would be. So in this case, that would be, and you would get 6561. Alright, number 73. Log base 4 of x equals 3. And again, keep in mind base, exponent, answer. So that would tell you what is 4 to the 3rd power. So that means x is equal to 64. Okay, so now let's look at solve the given equation if necessary around to 4 decimal places. 74 log base 2 of 2 plus log base 2 of a equals log base 2 of 13. Okay, remember when you have logs, when you have a plus, so you have those rules written somewhere. That's log base 2 of 2a. Means 2 plus means that you can multiply those two things. Equals log base 2 of 13. So then once you have it to a single log on each side, and they are the same, you can get rid of the logs. Technically the reason why you can get rid of them is because you can do this, and that way it gets rid of them. Kind of like that. I'm trying to cross those out. And so I'm left with 2a equals 13. So a equals 13 over 2. And there you go. 75, let's look at that one. You have log 5x plus 2 minus log 5 2 equals log 5 4. Keep in mind, dividing or minus means divide, so I'm saying log 5 of x plus 2 divided by 2 equals log 5 4. And again, single logs, cross them out. So x plus 2 over 2 equals 4. And now you're solving it like you normally would. The opposite of dividing is to multiply. And then I can subtract 2. And I get an answer of 6. Okay, easy peasy, not that hard. So far I haven't needed to round. Of course, that has to change. Why not? Okay, 76. What did I just do? Okay, 76 here. You've got 3y to the 40th, or 3 to the y power is 40. Okay, so kind of think like this. Why am I putting this question in here? I want to get rid of the y's. If I say log base 3 of 3y is equal to log base 3. Notice how I'm using the same number here of 40. Okay, this and this would cancel each other out, leaving me just the y. So then I can type this into the calculator and see what I get for an answer. The calculator gives me 35776. It says round to 4 decimal places. So 1, 2, 3, 4. This one would tell me that the 7 needs to become an 8. 3, 5, 7, 8. Bada bing, bada boom. There you go. So there's how you would solve that one. Alright, now let's get to the natural logs and the power of e. How come we didn't do that on the other one? I don't know. Maybe we'll see some more of those later on. 5e to the x minus 13 equals 10. Okay, again, idea here is to isolate the e. Then you can get rid of it later on. So add 13. You got 5e to the x is equal to 23. Divide by 5. So now I'm left with e to the x is equal to 23 over 5. Okay, so how do I get rid of the e? You get rid of the e by putting ln. And that means this would be ln. So these cancel out, leaving you x is equal to ln of 23 over 5, which is what you would type into the calculator to come up with an answer. 10 thousandths, really? Gosh darn. Okay, and I get 1.5621. Approximately. I may have been off because, well, it's getting a little harder to say double check and switch back and forth between stuff. Alright, so, but you get the idea. Okay, and then finally number 78, and this will be my last one for this one. 8 plus 7 e to the 5x, because, well, why not? Let's just have some fun. Okay, so I'm going to subtract the 8. That gives me 7e to the 5x is equal to 22. Then I'm going to divide by 7. Oh no, it doesn't come out even. That's okay. Leave it as a fraction. Okay, now I'm going to do the ln. So that cancels out, leaving me 5x. ln. Okay, you do that, you should get 1.1451. And then you would divide that by 5 because there was still this 5. And you get x is approximately equal to, divided by 5, 0.2290. 2290. Okay? And that's what you got to do. So again, remember the idea there, a lot of these, like these types of problems, even when they look different, the idea is to isolate something like this, do everything on the outside of it, and then worry about how you get rid of that. Notice we did that with the natural logs here with the ln's, and we go all the way back to the radicals, and we did the same thing with the radicals. We got the radicals by themselves, and then we could get rid of the square roots and then solve further from there. Okay, so one last thing I would like to make note of, number 79 and 80, omit. We will worry about those another time. Okay, so I will start part 4 with rational functions and rational expressions, because those you love so much. Anyways, y'all take care. Y'all do good. Thank you very much.